Sorry, let me stop. Okay, now let's start. Before I start the class, right, I gave us an assignment and only two people, or sorry, three people were able to join, were able to submit their assignment. So, Mr. Ahmed, even though you complained that time and you said you would do something to it, I did not get to see your assignments, which is not good enough. Okay, so let's continue. We'll talk about that after the class. So today, let's look at what we've done. Let's go to Google Colab. Okay, so we've done two projects, right? And at least, yeah, three people have submitted their assignment. So I guess almost everyone here know what is going on in this particular training session, what we are trying to do, and how we can apply it. So now let's look at this breast cancer prediction, for example. Let's go through it in case you were not here the last time we did it. So let's look at it. It's loading. Okay, let me try to enlarge it. Okay. Okay. Um. So now we have two type of breast disease in this case. We have a malignant breast disease, that is the breast that is not cancerous, and a benign breast disease, that is breasts that are cancerous. So in this case, we want to predict, okay, how do we know this particular girl or this particular lady has has cancerous breast disease? So that's what we are trying to do here. And then we import the necessary libraries, which are pandas, numpy. Then we import the sklearn libraries. So we have the standard scalar label encoder, and by now you should know what each library is doing, what library is doing. Sorry. So we try to read our CSV into our Google Colab. Then after that, we looked at some information about our data set. We get some, then we can see it is a limited data set because it's just a 569 rows data set. Then after that one, we looked at some data analysis. We checked some data analysis about it. Why is this thing again? Okay. So we looked at the shape. You can only see it is 569 rows and 33 columns. Then we called out all the columns here. So after that one, we looked at the diagnosis, that is the outcome. No way how to separate it to X and Y. We looked at the outcome column. Then we can see we have starting representing the malignant breast disease, then B representing the benign breast disease. So after this one, we need to download, sorry, we need to look, we looked at the first 5 rows so we can actually see. Now, in case you were not here the last time, now let me just try to explain what this mean. So we have breast cancer disease. This is a data set. We have like 569, but these are just like the first 5 rows, right? So when you go to hospital, they will get some information, especially if you have not you, but if someone has a breast disease, obviously they have to do some experiment, perform some experiment on her to look at the breast if the disease is cancerous or not cancerous. So in this case, you can see this is the patient's ID, then this is the diagnosis, that this is the final outcome. After all this test has been done, they can now assure the girl that okay, you have a malignant breast disease or you have a benign breast disease. So they looked at the mean radius of the breast, they got this, the mean texture of the breast, they got this. They looked at the perimeter mean of the breast, they got this. They looked at all this, they performed all these tests on that lady or on the ladies that were here. That they were 59, 569 ladies here, right? So and the outcome here is what we call diagnosis. And this what the outcome, the diagnosis or the result column is what we call Y. Why all the tests that are done on the women are what we call X columns. So now we try to look at okay, how many diagnoses do we have in this particular case? Remember, they were 569, right? So we can see we have benign case, that is breasts that are cancerous. There are 357 ladies, and breasts that are not cancerous, there are what 212 ladies. So we did label encoder. Why do we do label encoder? It was just that because our computer, our machine cannot understand letters, right? Does not know what M mean or what B mean. So we need to change this particular M. We need to change it to a number, a numerical data type, which is why we are trying to use a label encoder, that is help us to add label to it. Whenever you have M, maybe replace it with 0. Whenever we have B, that is representing benign, replace it with what 1. So we did that. That was what we did here, and then we looked at it again. So we can actually see here that where is it? The outcome now is not integer. That is, we've converted it into what? Into integer. So now the next thing is we dropped the column, the one that have empty spaces. That's unnamed 32. We dropped it. Now we are trying to separate it into x and y. By now you already know what x our x columns. You already know the values in the x columns. You already know the value in the y column. And obviously our y column is just a column which is representing the outcome column, while our x axis is all the column except the outcome column, right? So then we did, after we've separated them, we are trying to now train our model, right? The first process we did is what we call pre-processing. We are pre-processing it before we call our model. So now we are trying to now say we are calling our model, right? But before we call our model, we want to train our machine with, it's just like exam. They will teach you like 80%, then they will expect you to use your understanding of the course to answer exam question. So basically that's what we are trying to do. So we have 569. Let's say we are training it with 500 data sets, then we are expecting that okay, if I give this particular machine the 69 new one, it should be able to predict it accurately because it has looked through the pattern of the 500 data have feed it before. So that's what we are trying to do here. With we separate the X column into train and test. That is the training data set and the testing data set. Also, the same thing as our Y column, we separate into training data set and testing data set. Then we call our model, that is train test split. Then we did, okay, what are we separating? We are separating column X and column Y. So what is the test size? How many percent will the text size be? That is 20%. Then we did random state 42. So we looked at the S string shape here. We got 455 and 30 columns, and then Y test, we got 115 and obviously one column. So now we are trying to feed it into our model. So we call on logistic regression. So we fit our training data set into our model. Then we can actually see we predicted it, we looked at it, and we got almost 95% accuracy, which is quite good. That means for every 100 data set I'm feeding it, we return 95% accuracy. So after that one, we looked at the we looked at it, we checked if it was actually working. We check it if it was actually working. So we can see we have if the breast is malignant, or if the breast is benign, then we predicted it and we can see we have a benign data set here. So that's basically it for now. That's basically it. So yeah. So that's what we are doing. last time. So if you have a question, maybe you just don't understand something, or you think, or you have a suggestion, can you open the mic before we start what we have for us today?
I have a question, sir.
Okay. I can hear you.
My question is that M and B, I don't really get. Can you hear me, sir?
Okay, I can hear you.
Okay, I said the meaning of that M and B. I don't really get the meaning, like the full meaning of that
So,
M, the label M and B. And secondly, from that training this thing, I don't really get what you meant. Like after
okay.
the data set, the next line.
Okay. So now, let me just let's look at the meaning together. So we have what we call malignant, then we have benign. Now let's just check what malignant and benign mean. So if you look at this is malignant. So okay, I think I was actually the one that missed it. So we can see that we have malignant tumors are cancerous, right? While benign tumor are non-cancerous. So we have two type of breast disease. It is either the breast is cancerous. You know what cancer mean? So when they say a breast is cancerous, that means there are, I don't know how to explain it if you're not a medical person. But yeah, just imagine we have a cancerous breast, right? And non-cancerous breast, right? So whenever we say malignant tumor, that means it is a cancerous breast. When we say it is a benign tumor, that means it is a non-cancerous breast. So that's what this one means. We have two types. So let me try to scroll down. So now look at this, look at the diagnosis. So you can actually see that we have that benign. Sorry, I did the mistake when I was explaining the other time. Benign now means non-cancerous, right? While malignant means cancerous. That means in this particular data set, 357 people or 357 women have non-cancerous breast disease, while 212 breast women, 212 women have cancerous disease. Do you get what M and B mean now?
Yes, sir. Yes, sir.
Yeah, what was your second question again? Sorry. What's your second question?
I think next one, two, three, I think fourth or fifth line where you started your training this thing. I did not get that ahead. I think after the information, I think the down part ahead when you started the training ahead that part, yeah.
Okay. So what we try to do here, so we have different type of machine learning model. So one of them is logistic regression. You can mute your mic now. One of them is logistic regression. So what we just did is whenever we call model, this is what we call variable, right? This is a model. So logistic regression, then this bracket is just activating the model. So whenever we want to represent our model with what our logistic regression with model, that is whenever we call model, logistic activated logistic regression model should be will be active, right? So we have our training data set. Remember, we've separated them into training data set and what testing data set. So now we are trying to fit our what is model again? That's logistic regression. That's our machine learning model. Then we are fitting. What are we fitting? We are fitting the training data set and training Y data set and training X data set into the model, right? So when we fit in, we got this answer here. So now we are trying to look at the accuracy. That is, how accurate is my model? How is it performing? We can see we have for accuracy now on training data set. We have 94% on testing data sets. You know, when you read your book, 94%, you understand everything and you can grade yourself 94%. So you actually took the exam, right? And we can see he have this particular model, this particular machine learning model can get 95.6%. That's 0.956. That's 95, and that's almost 96%. Right. That means this model is doing good. And basically, that's what we did here. So now we are not trying to test our model if it is doing well. So now we imported some the values, the dataset values there. Then we said, okay, if it is zero, reply with malignant. If it is one, reply with it is benign, right? So so then it is saying this particular information is malignant, and we actually did a lot that day. We checked the one that were malignant and the one that were benign. So that's basically what we did. Do you understand now? Do you understand that now?
Okay. Okay, sir. Thank you, sir.
Yeah. So today we will look at different machine learning model that we have. Um, Let me check.
That's fine.
So we can see here we have only two models here. So let me try to rerun everything. Let's run everything again. Or it will give an error. Let me just let me upload my sorry. Let me upload my PS data set here. So it won't upload anywhere. It's uploading. Okay, let's run it again now. Everything has run. So we have an error here. That's error. Okay. As a I think something is happening. Okay. I think that's it. That's it. The item out of the items. So sorry, I want to do something. Think I do. Where you see it? Okay. German. German box. Hmm? My box. Why? Sorry, I'm trying to debug this thing. Alright. Let's try to I want to remove a column. That's basically what I'm trying to do. It is giving me an error. So it said ID is not found again. So now you know what. Okay. Okay. I can't remember the because I'm seeing here. Let me show the error. It is saying that X has 30 feature, but logistic regression is expecting 31 feature as inputs. So definitely I must have deleted a column which I can't remember currently because this is what we did last week. So let's do another one. Let's start a new one from the start. Now let's go to our Google Colab again. Something that I love to see anyway. So yeah, we have different type of what do you call it? So we have different type of machine learning model. So as I said earlier, that today's class will not be too long at all. It will just be a very short data set. Sorry, a very short class. So we have different type of machine learning model. We have, let me just list them. We have our linear model. We have linear model. We have logistic regression, and I think I've used linear model and logistic regression. So I'll just explain when and how to use it. We have linear model, we have logistic regression. Let me just list it out. We have logistic regression. We have support vector machines. Most of the time, we usually call it SVM, support vector machine. So that's what we call SVM. So machine. Then we also have K nearest neighbor, K nearest. So most of the time we call it KNN, K nearest neighbor. What else do we have? We have RG boost, RG boost. We have random forestry, random forests, random forestry. We have ADA boost also. We have random tree classifier, random tree classifier. We have random tree classifier. What else do we have? We have RGB, we have KNN. We have a couple of them like that, but let's just explain this. Now, let me try to outline. What's it?
XG boost.
Yes, we have. You said something. Sorry.
I said XG boost.
Yes, yes. XG boost. Thank you. We have XG boost. XG boost. So now let's look at what we've done. We have our linear model logistic regression support vector machine, which I said they call it SVM. We have our k nearest neighbor. We have RG boost. We have XG boost. We have random forestry. We have random tree classifier. We have other boost. We have naive bias. We have decision tree. So we have SG boost also. And let me try to include our okay. So now to use linear model is mostly used when you are doing one by two classification. That is, how do I explain this thing in a simpler way? Okay, so if you are trying to do something like yes or no, maybe like it is positive or negative, that kind of thing. The one we did the last time, which is it is either it is cancerous or non-cancerous. So you can use linear model for that one. So logistic regression, you can also use logistic regression for that one. But most time, logistic regression is used for more than two classification. Let's say we are trying to classify people into different race. Let's say if you have this particular strength, if you have this color, this color, if you have this strength, if you have this facial expression, everything has been converted into number. Then you are trying to classify them maybe like two or three. Maybe you are just classifying them into white, black, and Afro American. That is white, neither white nor black. So that's when we used mostly, that's when we used SVM and logistic regression. But linear model is used to when we are trying to classify two things. Maybe we are trying to classify it is either cancerous or non-cancerous. That's what we call one by two classification. Or if you are trying to do maybe you make profits or you lost, you understand? So that's just one by two. That's when we use linear model. But logistic regression and support vector. You see, from K nearest to except naive bias, this one, but from KNN, RGB, RFR, ADAPUS, random to classifier, decision to edge, RGB string, except this naive bias. So we use them when we are doing complex thing, especially when you see forest, from the word forest, you can see how many branch they have. It's just like a tree. How many branch does a tree have? You can put place a you can put a number to it, right? It's more like maybe 20. That means if you're trying to classify a a lot of things, let's say we are trying to classify we are trying to classify the country. We have like 194 country. But now let's say we have some information about the country. That is, if your GDP is between this is your GDP, this is your land mass, this is your population, this is your we are trying to let our machine predict what type of country is this. You understand that? And we have 194 countries. So you are expected to use a big machine learning model. You will not We are not expecting you to use linear model. They're expecting you to use random tree classifier, decision tree. They are expecting you to use argb boost because they from the word tree, they they there's actually a math behind this, right? And if you actually start doing the math, it is boring a little bit. And I've vowed that when I started this code that I will make it as interesting as possible. So when you see, it is actually cool if you can learn the math behind it because I can see the math currently, but yeah, I can't show you. So the tree, it's more like before you get to the final gate, they keep scrutinizing you. Let's say you are going into a bank and that bank is prone to thefts. So you have 20 security check. So there's high probability that if you eventually gain access to the bank, you will be without any weapon, right? Sorry. You will be without any weapon. Okay. So sorry. So you'll be without any weapon. So they will check you first time, second time. That's the same way these three are working. They will keep they will keep on training the data sets. It is a tree. After the first branch, they will retrain the model, they will retrain the model in countless number of times. So then when you actually, by the time you check for the accuracy, then you will see something like 97%, 90, because they keep training themselves. These are when this particular um tree are these are when particular model, they are very, very important. Now the next one is naive bias. Now this naive bias is when we use unsupervised machine learning. So when we started this machine learning, we said we have four type of machine learning. I'm sorry, two type of machine learning. We have the supervised machine learning, then we have the unsupervised machine learning. So the supervised machine learning are the one we have been doing, the one you can easily say it is either you lost or you gain. That is the one that have outcome basically. The one you can say um we have cancerous breast or we have non-cancerous breast. So that's what we call supervised, something that have an outcome. You can easily see the outcome column there. But unsupervised, now let's look at our email. If you look at your email app, you will actually see there are some mails that will be classified as promotional mail. There are some mails that will be classified as primary mail. Please give me a minute. Okay, so you will see some they will be classified as promotional mail. They will see some they will be classified as um primary message. You will see one that will be classified as spam. So all these one that are classified as spam. But when I'm sending a message, I don't get to say this is the outcome. That is, help me to classify it in under spam, help me to classify it under under normal or under primary mail. So these are the ones that do not have outcome, and that's what we call unsupervised machine learning. So we use naive bias to classify them into unsupervised machine learning model. Right. That's what this one we now converted all the mail into number. Then they have a way to do it, right? So we still look at that one soon. So now what is left for us in this particular training cohort is that we want to build a web app. So the web app will look like something like this. Now, it will look like, but to actually build the web app, why we stopped a little bit was that we are actually supposed to, because our Google Colab cannot build the web app. So have you heard about if you have Anaconda, that is the Anaconda package on your phone, on your laptop, you can also use that one of the apps there to build a web app, something like PyCharm, Spider. You can use that. But in this computer, we have Visual Code. So let me just open that. So let's look at it. I'll just explain how it look and how it work. VS Code. So now let's just open it and look at how it looks like. So someone is actually using this before. This is not what we'll be writing, but don't be scared, right? This is not my laptop. Like I keep saying it. So it's more like an HTML thing. So it is very easy to look at. So just like what we have been doing, these are just different tabs that this person has opened. So this is just front end, but we are not doing anything of this. But I just want to explain how it works. Can you see? We have the person is working on this and writes this. We have all these things. So they are very easy. So we will we will create our own tab also. We can see this is a Netflix tab. Let me just so we have our we create our own tab also. Then we write some codes like this. They are very easy because we've already written our own code on Python on Google Colab already. So most of the time we just do something like this. We just do something like this title, but we'll be using Streamlit. So we write something like st.title, then we give it a title, then we do something a little bit similar to this, but not exactly. It doesn't look this complex. Don't be scared. And as I said, this is not what we are out to do. This is just front-end engineering, but it looks closer. But don't be scared about the code. That is, it looks scary. No, it doesn't. It's not like that. It's not like this per se. But there are some things we can just look at. We can look to it. So we have our title. What this particular person is trying to do is he's trying to build the front page of a web app. So now let's try to look at it. So it is saying that the languages. So anything you want to learn is quite simple. So it's saying the language here is English. Then the header. So we have our character. That is the character. We have the UTF-8. So we have our name. I won't be explaining everything, obviously. We have the title. We have edutech concept. That means the front end. What we are trying to build is what is an edutech concept. So now, it's more like you want to write a letter. You have the head, you have the body. What will be under our body? We have different class, we have different button, basically. So the first button will be a navbar toggler. So that's basically what we want to do too. We have different body, we have different button, then we have different codes here. So instead of writing all this class code, so let's say we want to classify, we want to build a button here. When we let's say we are trying to look at
Oh, please, sorry, I can't hear you again.
wait, you can't hear me? Oh my
Yes,
god. What was that thing you heard? Sorry.
you're explaining the body of the button. Not what I had last. You're explaining button.
Oh my goodness. Okay, and I've been saying something now. Okay, so okay, I was explaining the button. What was that thing? Okay, so I was trying to say the last time we talked, and what I used to explain the last time was that GPA app. So you know what GPA mean now? That's the grade point in university setting. So now let's say we have a grade point app. We have to there will be some empty space you need to fill. Maybe the grade you are expecting or the grade you've gotten already. Now let's say for agriculture you got B and it is 2 units. You have to fill all of those. For maybe economics you got A and it is 3 units. Maybe for engineering you got B. So you have to fill all the courses. Then you now click on one final button that will now classify if your that will now tell you your old grade point, that is your old GP. Maybe after everything it falls under 4.89 or 4.11 or 3.5, all of those things. That there is one final button. So basically, that's what we will be doing in this part in our own body. Under our own body, we will try to give some empty space. That is like, let's say the empty space um will be all the field we expect you to fill. Something like, let's say, the texture of the breast, then we give an empty button here so that you can fill it. Then you do so under our own body instead of all this class. That would be what will be under our own body. So then after that one, then we click on one final button there. So we'll not be doing all of this thing. So we click on one final button. So the final button will be the one that will calculate it. So yeah, it's a little bit similar to this. So I guess we need to download VS Code. So either tomorrow might be a break. So we actually have let's look at what we have together. Today is 22 and we have almost a month. We have 30 days to finish it. So what is left for us basically is how to build a web app and how to classify unsupervised learning. So most especially we can finish that in 2 weeks. And I don't want us to jam pack everything together. I don't know if you understand. So maybe after today, I'll leave us to we our next class will be on Saturday. So that next class on Saturday, I'm expecting everyone to have watched whatever we've done before. Or in case you've not submitted your assignments, please and please try to submit it before the next Saturday. We'll not be having class tomorrow. And also try to how do you say it? Try to download VS Code. That's Visual Studio Code before the next class, right? So it is very, very easy. And also, what else? So by the time we return, we'll be building our web app, then we'll be doing unsupervised learning. By that time, it will be a little bit fast. And yeah, I should be able to get my computer at that time, so it will be a little bit easier for us, everyone. Yeah. So yeah, do you have a question? Because we are basically done for. I'm just what I did today is just trying to let you know the different type of machine learning model that we have, and we have succeeded in doing that. So do you
Um,
have any questions?
Sorry, please, I do have a question. So the way it is now, like for this web app that I want to build now, is to make what we are doing more user friendly. Should in case anybody wants to use it to like check.
Exactly. So it will not be, when you write code, when you say I build a machine and you cannot deploy it for the public to use, that
Yeah,
means the machine
they
is
cannot
only
be going to
working.
the back end every time.
Yeah. So it
Okay.
cannot, what we've been doing is actually the back end. So we are trying to do a front end. Front end is just like what user will interact with. Do you
All right.
get?
All right. All right. Yes. And some another thing is that since we work with like a large amount of data sets, but not all amount of data sets, like we don't even want to tell somebody to like fill in those gaps. We've not actually had the data of that person before. So like can we deploy this for like very serious cases like this cancer case? Because if you tell somebody that has like bring all these things now and the person is not saying, okay, let me check if I actually do have cancer, whether I have malignant or benign, whether it's one of the two for diagnosis, and the person eventually says something like malignant instead of benign because of the model was not like 100% accurate, or the result we got is not actually precise. So does it can it be used like for like public use, like with critical situations like this?
So when it is pertaining to health, it is not. Now let me say the reason I said this. So remember the data set we feed this thing, we got it from Kaggle. So it may just be someone who sat down in his or her house, right? Just trying to random number, just putting random numbers there. So now let's say a real patient is now trying to use it. So if the real patient use it and it gives the person a cancerous breast disease, which the person does not actually have, because it is cargo data set, it's not gotten from a verifiable source. So if you're actually trying to build what a patient will be using, that means you will get your data set one from verifiable source, and you will not use number like 569. That's too biased, that's too small. You can start from 100,000. And that's why this open AI, when you look at ChatGPT, if you actually look at the back end of ChatGPT, they are pulling data from different sources, that is from Google, from all the web. Let me just say that they are pulling data from different sources. So whenever you ask it a question, there is low probability that ChatGPT will not know it, because every information is present on the web, right? So if you want to build something that's very critical and it is usable for patients, you actually start, you will do a real work. You get your data from a verifiable source. You don't want to use a small data set. You want to use like above 10,000, 100,000, a million. That is all the data set that will cover almost all cases of data set. Now let's say I'm trying to do something like racism now. I know we have like 5 or 6 race. We have the black, we have the white, we have the Hispanic. Sorry, let me try my laptop. So we have the black, we have the Hispanic. We have like 6 type of different race. So in that case, I want to feed my computer with different, let's say, maybe like all the, let's say it is breast cancer now. Almost all cases of breast cancer, I want to feed as much as possible. I want to feed my computer so it will actually know that it will know different case of breast cancer. So if you as a user is using it, no matter your number, it will the computer will have seen it before in its own training data set, and it does not need the computer does not need to you to put the same data set, the same number as what we've put on our training data set. I don't know if you understand, but when we build a
Yeah,
web app,
I'm getting what you're saying. Like, it is not
when
advisable because we have to get like
it,
a large amount of data before we
yeah,
can now
so
conclude. All right.
and if it is health, it is very, very critical.
Very, very,
Please
yes,
don't,
very serious. I understand.
because imagine you tell someone you have a cancerous breast. The person might, even if it is not true eventually, the person might develop high blood pressure. And you already know that high blood pressure is can cause multi-systemic dysfunction. Sorry, that was about that. Okay. So now when you have HBP, you can develop cardiovascular disease, that's heart disease. When you have that, it can affect kidney, it can affect, that's what we call multisystemic dysfunction, basically. That is when you have heart blood pressure, HPP, it can affect your heart. When the heart is not working very well, it can affect the kidney. When the kidney is not working very well, no matter the drug, it can affect the liver. And a lot of organs are already deteriorating just from the person using your app, because this data source is not from a verifiable source. Please don't do it if you are not using that for. Don't do it for health, please. It is very critical when you are using it for health. And but I will just show us how to build a web app. But you have to put a disclaimer whenever you are using it that please don't use this. The data is not from a verifiable source. If at all you will put it out there. Do you get that?
All right. Thank you. Thank you.
Okay. So no problem for now. So we meet next Saturday. Do anyone have any question, any concern, or maybe um um anything? Okay. So that's why we put an end to it today. Thank you so much for joining. Have a great day, everyone.
Thank
Bye.
you very much.
You're welcome.